Okay, so let's talk about substitution with multiple equations to solve for multiple variables. First of all, let's go back a couple of sections, couple of lessons to a note, okay? If we're given a term or a configuration of lines that look a certain way, say negative x, which is just 1, 2, 3, 3 lines, they look a certain way, and it is equated to something else, and we're asked to solve an equation where we see that same configuration of lines, 1, 2, 3, it's the exact same term, they look exactly the same, then the thing that that term was equated to can be directly substituted in, okay? So that means this is the same, 1, 2, 3, as 1, 2, 3, they're exactly the same. So that means that this 5 can be directly substituted in. Y equals 5 plus 1, which equals 6. Why is that 5 positive? Okay? Because this is just a configuration of lines, okay? That's all it is. It's blob. It could be anything. It could be a cloud. It could be a triangle. It could be anything. It's just blob. It's a variable. It's something that's standing in for something else, okay? Now, if we were instead given, let me change my color. Hopefully this color works. If we were instead given the equation, yeah, it does work. Y equals negative y plus 1, or not negative y, sorry, negative x, that configuration of lines here, 1, 2, 3, 1, 2, 3, 1, 2, 3, that 5 can come right into here, okay? So let's rewrite this. Y equals, there is a negative now, okay? And in this little box, we have this substitution of that 5 plus 1. So now that 5 is officially negative, okay? Because we said negative this blob, negative this term, negative this configuration of lines, okay? That's how it is now negative. Y equals negative 5 plus 1 is negative 4, boom, okay? But up here, it's just the exact same thing. Negative x, configuration of lines, term, pony farts, blob, cloud, triangle, does not matter. Same thing, direct substitution. Okay, so let's move over here. Substitution with multiple equations to solve for multiple variables. Multiple variable. We have an x and a y, and we have an x and a y. So we're going to go with our first equation, x plus 2y equals 10. And actually, let me make sure that you can see this over here. Yeah, you can. Okay. All right. So let's go ahead and solve for x first. So we know to solve for x, all we're going to do is take the 2y, subtract it bring it over here to this side, and that'll give us our x, okay? So x equals 10 minus 2y. All right? There's another way that you can configure this same equation over here. You can also say equals negative 2y plus 10. Either way works, doesn't matter, same damn thing. Okay. Now what we're gonna do, we found x up here. We're gonna plug that x, whoop, in over here. But you're gonna say, well, whoa, wait a second. This configuration of lines does not look exactly like this one. No. Excuse me, hello? There's only 2 lines over here. 1, 2, okay? Over here, there's 3. 1, 2, 3. That's a negative x, and that's an x. I'm gonna have a heart attack. That's not okay. No. Okay, well, here, like in one of our other parts, that is a negative 1. Negative 1 times x. So, let's rewrite this, okay? Let's not worry about substitution quite yet. Woo. Let me do this. Yep. Oh. Let's rewrite this to make us all a little happier. Negative 1 times the quantity x plus 4. Well, look at there. All of a sudden, they look the same. They're the same term, right? Okay, so we've got y equals negative 1 times the quantity. We're just going to use this top one up here, make it simpler. Oop. 10 minus 2y plus 4. Okay, so our last lesson, our most recent lesson, we talked about distribution, right? So we are going to distribute this negative 1 through this expression, right? What did we say about expression versus equation? Equation is equal to something, you see an equal sign in it, and expression has no equivalent. So we are going to distribute that negative 1 through this expression. So let's do that. And again, distribution is multiplication. So y equals negative 1 times positive 10. Negative times a positive is a negative. So we have negative 10. Negative 1 times negative 2 is a positive. Negative times a negative is a positive. So plus 2y, okay, plus 4. All right, now, combining like terms, this is a constant and this is a constant. Y equals negative 10 plus 4 is going to give you negative 6 plus 2y, okay? We're going to need more space. Let's erase this. Okay. Let's come over here. We've got rewrite this. Let me just double check things. Yep. Okay. So once again, we're gonna combine like terms. So let's move this y over here, combine like terms, y, combine like terms, y minus 2y, we're going to subtract 2y from both sides. That cancels out. Y minus 2y means negative y equals negative 6. Negative 1 is understood to be right here. Okay, so we're going to divide by negative 1. That negative cancels out. Divide by negative 1. Negative divided by a negative is a positive. Y equals positive 6. So there we have our first variable, okay? Or the answer to our first variable, y. Boom, there's 1. Now what we're gonna do is we're gonna plug this sucker back into here, okay? We're gonna come up here. We're gonna plug this back in. X equals, let's, boop, travel this back over here. X equals 10 minus 2 times the quantity, y, right? Because that 2 is 2 times y. So 2 times the quantity y. You have a configuration of lines, a term, a blob, whatever, y, okay? Y. Y equates itself to 6. 6 can directly substitute in for y. So x equals 10 minus 2 times the quantity, 6, okay? Equals 10 minus 12. Once again, PEMDAS, right? Please excuse my dear Aunt Sally, order of operations. Multiplication first, okay? 2 times 6, 12. 10 minus 12. X equals negative 2. There you've got it. Those are your 2 answers. X equals negative 2, y equals 6. You can do this with however many equations you have. So if you have 5 equations and 5 variables, you can do that. If you have 7 variables, you need 7 equations. If you have 3 variables, you need 3 equations, okay? However many variables you have, that's how many equations you need. All right. Let's see here. I think that'll be it for this lesson. So that was substitution. We did a little bit of PEMDAS. Oh, did a little bit of what times what equals a positive. All right, next, I think we're going to do some solving for a variable, exponent, maybe, some logarithms, and then working with units on the top and bottom in the numerator versus denominator. All right, it's the plan.